When you think of space, you might just assume that, apart from the odd planet and star, it's kind of, well, empty. As it turns out, thanks to the sun, there's actually a lot of unseen forces at work.
When a spacecraft is sent into space, it's bombarded by all sorts of charged particles like electrons, ions, photons, and these strike the material surface. And it causes collisions inside with other electrons that cause them to scatter and be released. This is really similar to the process of billiards, when you're breaking. The cue ball gets hit and launches into the balls, hits them, causes them to scatter everywhere.
So depending on the amount of electrons added or removed, it can produce a charge. And when it comes to satellites in space, well, it goes without saying, it's a bit problematic.
This is a really large problem for spacecraft, and it causes the majority of space-induced spacecraft failures for satellites.
So to help spacecraft engineers, Trace and his collaborators have refined and added to a database of materials that scientists can reference to see what materials do better or worse under this stress.
So we started from a database that was made in 2001 that just had the data. It didn't have any of the fitting parameters that engineers would need to use. And then we went into literature and collected hundreds of articles of data. We went through their research, characterized the samples that they used in order to categorize them.
They also did some testing of their own in this kind of crazy looking vacuum chamber, which works by blasting materials with ions and measuring how many electrons get scattered back.
Here we're able to take very precise measurements on samples, so we incorporated a lot of the measurements that we took here at Utah State into the data sets.
And this data set has already been used by NASA for several missions, including the James Webb Telescope and the Europa Clipper mission. So the goal is that this database can continue to help NASA for future missions.
This database has the potential to help engineers better design their satellites to reduce spacecraft failures.